Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 2, Notes 2. Today we're talking about graphing systems of inequalities. So our learning target today is I can graph systems of inequalities. Yesterday we talked about systems of equations pretty heavily and how to graph them and where the solution is on a coordinate plane when we graph them together. Today we're going to talk about systems of inequalities. Now, inequalities are where we have that shaded region on the coordinate plane to give us our solution. So if we have a system of inequalities, we have a set of two or more inequalities on the same graph, and the solution set is where those shaded pieces overlap. So the shading for this line is that yellow piece, the shading for this line is that purple piece, and where the purple and the yellow overlap, that's the solution to the whole set of inequalities. So that's what we're going to be looking for today. We're going to be looking for where those shaded pieces overlap. So let's take a look at number one. Now remember, when we're graphing inequalities, the best thing we want to do, or the first thing we want to do, is to make sure they're in slope-intercept form. Get y by itself. In number one, both of them happen to have y by itself, which is fine. And then the other thing that we need to make sure we do with inequalities is decide how to graph them. What kind of line are we using and where are we going to shade? So for this, y is less than negative x plus 1. I want a dashed line and I'm going to shade down because less than means I go down. For this one, I want a solid line and I'm still shading down. So then let's put both of those lines on the coordinate plane. I have a y-intercept of positive 1 for the top line, and then a slope of negative 1, so that's down 1, right 1, down 1, right 1, down 1, right 1, and so on. And this is a dashed line, so I want to dash that all the way across the coordinate plane and shade below it, so that's out this direction. Now when I shade these things, especially when you're using pencil, which is this, you're not going to have different color options to choose from. I kind of shade straight out, or in other words, perpendicular from the line, so that I know where that shading came from. My other line would look like this. I'd start up at positive 3 and then have a slope of 2. So up 2 over 1, up 2 over 1, or in other words, down 2 and back 1, down 2 and back 1. Now this one is a solid line, so I'm going to fill it in, but I'm still shading below. So I'm going to shade underneath that line. And then you can already tell, remember our solution set is where the two overlap. So the purple and the red overlap down here. Now on your page, especially if you're using pencil, if you're using the same color ink from your pen, you want to just darken that in. Darken that region in so that you can see where the solution set is. All right, there we are. Let's take a look at number two. In number two, I have y is greater than x plus 1. That's going to be a dashed line that goes up. Dashed and up. And the bottom line, y is less than x minus 3. That's going to be a dashed line that goes down. Dashed and down. So first line, start up at positive 1, slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1. And this is a dashed line. And this one I'm shading up from. So I'm going to go above the line like this. And then the other line is y is less than x minus 3. So slope, or y-intercept of negative 3. And slope of 1, up 1 over 1, up 1 over 1, up 1 over 1. And this is also a dashed line. But this time, I'm going to be shading down. All right, so some of you may have recognized this before we even started this line. Our slopes here were the same. Our slopes were positive 1 and a positive 1. Those were supposed to be circles, not zeros. Our slopes are positive 1 and positive 1. That's the same slope. That means they're parallel lines. And we all know that parallel lines are never going to touch each other. So here's the thing. The top line was shaded out. The bottom line was shaded out. They were both shaded away from each other. And since these lines are parallel, they're never going to touch, which means there's never going to be a point where these two regions overlap, which means this is a system that has no solution. Now it's rare in inequalities because there's almost always some point where they'll cross over, but it is possible. So parallel lines where the shading goes out, that is a system that has no solution. And again, that's a rarity. That doesn't happen very often, but it is possible. So let's take a look at number 3. Now in number 3, our lines are not in slope-intercept form, so I'm going to start with that first. On this top line, I need to subtract the 3x over, so I'd have negative y is greater than or equal to negative 3x plus 6. Notice that there was a subtraction sign in front of the y, so when I got rid of the 3x, that was still there. That's important because now I need to divide by negative 1, and that does a couple things. One, that changes the sign over here for all this stuff, but two, it also flips my sign, my inequality symbol. So I have y is less than or equal to positive 3x minus 6, and that's the line I'm going to graph. The other line is a little bit simpler. All I need to do is move that 2x over, so I'd have y is less than or equal to negative 2x plus 4, and there's nothing to divide by. So here's one of my lines, here's the other line. Now I'll put them both on the coordinate plane. I'll do the purple one first. So I start up at positive 4, and then my slope is negative 2. So down 2 and right 1, down 2, right 1, down 2, right 1. I forgot to list my choices for this one. This one is going to be solid, and I want to shade down. So here's my solid line through those points. And shading down would be like climbing up the mountain and crawling into a hole or a cave, and that's down this direction. Okay, let's try the other one. I'm going to put the other one in red. So I start down at negative 6, and then my slope is positive 3. So up 3 over 1, up 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1. I again forgot to make my choices. So this is also a solid line, and I want to shade down again. So solid line and shading down. So we can already see where the overlapping region is going to be. So I'm following these two lines right here and shading all of this stuff. Again, it really helps if you darken that shaded region in so we can clearly see where your solution set is. Let's try number 4. In number 4, I have x is less than or equal to 3, and I have x plus y is greater than 2. Now, the top line can't be solved for y because there is no y. This is a vertical line at x equals 3. Okay, when I have no y value, that means I'm looking at vertical lines. This bottom one, I just need to move my x over. So I have y is greater than negative x plus 2. Okay, so the top line is going to be solid, and I'm going to shade down, and we'll talk about what down looks like on a vertical line, because there is no down when you're looking at a vertical line, but really we're going to be shading to the left. This one is going to be dashed, and I'm going to shade up. All right, so starting with the top line, I'm at positive 3 for an x value, and I have a vertical line, and I want it to be solid, so I really just have a vertical line through 3 like that. Now, when I say shading down, down could have quotations around it because there is no down when you're looking at a vertical line. But if I'm thinking of x being less than 3 would be 2, 1, 0, negative 1, and so on. They're all in this direction. So I'm shading this way. Okay. The other line, I'll throw that one up there in green. I start at positive 2 for a y-intercept, and then I have a slope of negative 1. So down 1, right 1, down 1, right 1, and so on. And this is a dashed line. So that line looks like that. And this one I'm shading up. So I go this direction. Okay, so I probably should have said this at round number 1. It helps if you shade the first two kind of lightly, especially when you're using a pen. But if you shade those first two kind of lightly and then darken in your solution set like we've been talking about. All right, there it is. Okay, two more like this. And then we'll do some more problems on the back. So number 5, now I have y is greater than 3. So no x variable here, which means no slope, which means this is a horizontal line. And I know I want it to be dashed. And I know I want to shade up because it's greater than. The bottom line, y is greater than negative x plus 4. This is a normal sloping line. My slope is negative 1. I want this line to be dashed and shaded up as well. They're already in slope-intercept form. Both of them are solved for y, so I'm ready to go. I'll put the top line in purple. So I go up to positive 3 for a y value, and I have a horizontal line there. Ooh, that's supposed to be dashed. Sorry. See, this is why you decide first. To catch yourself from making that mistake. And then I want to shade up. So there's that one. Then I'll do the bottom one in red. Y is greater than negative x plus 4. So I have a positive 4 y-intercept, and then I'm down 1, right 1, down 1, right 1, down 1, right 1, so on. Dashed line. That was supposed to be dashed. I just didn't pick it up very well. Dashed up here. And shading up is like that. And again, the solution set is where they overlap. So we kind of have this little trapezoid shape right here. All right, one more just practice graph. Both already solved for y, so that helps. That makes life a lot easier. The top line is going to be dashed and shade down. The bottom line is going to be solid and shade up. I'll put the top line in blue. So I start at positive 2, go up 2 over 1, up 2 over 1, up 2 over 1, dashed line. And shade down would be this direction. And then the bottom line, I'll throw that one up there in green. It's hard to see on that green, sorry. Y is greater than or equal to negative x minus 3. So start at negative 3, and you have a negative 1 slope. So down 1, right 1, down 1, right 1, down 1, right 1. And then solid is what I'm looking at. And I want to shade up. All right, so my overlapping region is in here. And you can darken that in. It's kind of a big one. It's almost half the coordinate plane. So use those lines as boundary lines. Find your overlapping region. You know, that's my one boundary line. That's the other boundary line. And shade it all in. All right, let's flip it over to the back and talk about a couple of word problems here. In number 7, it says the most Jack can spend on bagels and muffins for a cross-country team is 28 bucks. Package of 6 bagels costs $2.50, and a package of muffins costs $3.50 and has 8 muffins. He needs to buy at least 12 bagels and at least 24 muffins. So I have 2 things that I'm purchasing here. One, I should say Jack has 2 things he's purchasing here. One is the bagels, so I'm going to call that X. And the other one is the muffins. So what we want to figure out is what are the different options of packages of muffins he could purchase. So the first thing I need to do is I need to write a set of inequalities that is going to be my solution on the graph. A couple of these inequalities are easy. If I think of the fact that he has to have at least 12 bagels and the fact that there are 6 in a package, that means that he needs to have at least 2 packages. I should have said that X is the packages of bagels and Y is the packages of muffins. And the reason that is the case is because that's what the money is based on, is the fact that it's a package of muffins and a package of bagels. If he needs at least 12 bagels and 6 are in a package, that means he needs 2. So X has to be greater than or equal to 2 because he needs at least 2. For the muffins, he needs 24. A package contains 8. That means he needs to have at least 3 packages. The last inequality is where I have to put the money together. So I'm going to take what's being charged for X, that's 250, so 2.5X, plus the 3.5 for Y, and that has to be less than or equal to the $28 that he has to spend. Now, those are my inequalities that I'm going to throw on the coordinate plane. Now, the first two are easy to graph. This is going to be a vertical line at 2. That's going to be a horizontal line at 3. This one I need to put in slope-intercept form. And when I took the time to put that in slope-intercept form, it looked like this. Y was less than or equal to -5/7 x plus 8. So all I did there was solve for y, which you've seen me do a lot in this class. So now let's put them on the coordinate plane. So they're all solid lines. That helps. The vertical line at 2 is going to look like this. And I'm going to shade in the greater than direction. All of this stuff over here. So already a lot of the coordinate plane is shaded. Then I have y is greater than or equal to 3. So I go up to the y value of 3, 1, 2, 3, and I have a horizontal line, solid line, at 3. And again, I'm shading up. So that's a good overlap to start with. Then the last line is going to be a little bit different. It's going to actually be a diagonal line with a slope. I start up at +8. So that was 3, 4, 5, 6, 7, 8. And then I go down 5 and right 7. That's down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6, 7. And again, I have that slope because of how I solved for y. So this is my solid line there. And that's a solid line that gets shaded down. So now think about our region that's filled in. Here's one boundary line, here's one boundary line, and here's another boundary line. It's this little triangle in the middle, which kind of makes sense because we have 3 lines that affected this coordinate plane. 3 sides make a triangle. So there's the shaded in overlapping region. It's a pretty small one down in the corner. But then if we look at the last part of this question, it says give an example of 3 different purchases he can make. So anything that's in this black region here is a solution to the system. So let's say I go over to 4 and up 1, 2, 3, 4. That's a solution. So he could have 4 packages of bagels and 4 muffins. Okay. I could go over to 5, 6. 6 and 4 is still in there. It gets pretty close to that boundary line, but it's still in there. So I could have 6 packages of bagels and 4 muffins. Or I could have something like 3 packages. Oh, this was a 3. I'm sorry. That was a 1, 2, 3. Yeah, that was 3 packages of bagels. Oops. 3 packages of bagels. 4, 5. Then this was 5 packages of bagels. I swear I can count. Okay, so then if I go over to 2 packages of bagels and I go up 1, 2, 3, 4, let's say 5, I could have 2 packages of bagels and 5 packages of muffins if I wanted. I could even have 6. Okay, so the point being is that anything that's in this black region is a solution, is a combination that he can use. Okay, let's take a look at number 8. In number 8, it says, Rondell makes $10 an hour cutting grass and $12 an hour raking leaves. He cannot work more than 15 hours per week. Graph 2 inequalities that Rondell can use to determine how many hours he needs to work at each job if he wants to earn at least $120 a week. Okay, so 2 things happening here. One is cutting grass, one is raking leaves. So I'm going to say X is cutting the grass and Y is raking the leaves. Okay. Now I have an equation or an inequality that I need for the hours, but I also have an inequality that I need for the money. So if I think about the hours, he can cut grass for a certain number of hours and rake leaves for a certain number of hours, but he can't work more than 15. So that has to be less than or equal to 15 hours per week. Then the other part of this is he earns $10 an hour cutting grass, and he earns $12 an hour raking leaves, and he wants to make at least $120. So that's greater than or equal to $120 in a week. Okay, so that's my system. Now I'm going to put them in slope-intercept form and graph. The top one is easy, just move the x over. So I have y is less than or equal to negative x plus 15. The bottom one's going to take a little bit more work. I have to do some division too. So move the 10x first. That's 12y is greater than or equal to negative 10x plus 120, and then divide by 12. So y is greater than or equal to negative, I'm going to reduce this fraction, 5 over 6 x, and then 120 divided by 12 is 10, plus 10. All right, so I'll throw the first line up there in purple. I want a y-intercept of positive 15, so let's count up 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's my y-intercept for that one. And then I have a slope of negative 1, so down 1, right 1, down 1, right 1, down 1, right 1, and so on. This is a solid line. Kind of like that. And I want to shade below it. Then the other line, I start at positive 10. Notice that I marked the 10 on this coordinate plane because I knew I was going to need that later. So I start at positive 10 for a y-intercept, and then I come down 5 and over 6. So down 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6. See if I can do that one more time. 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5, 6. So it's really close to the slope of the purple line, but it's not exactly 1, or negative 1, I should say. This one shades up. Okay, so the shaded region between these two lines is kind of the goal or the possibility that of all the scenarios he could do, the number of hours that he could spend cutting the grass and raking the leaves. Okay. One last question that we're going to look at, no, I'm sorry, two last questions, and these are just graphing inequalities that have more than two. Sometimes we have systems of inequalities that have more than two, which means we have to put more than two lines on the coordinate plane. So first thing I'm going to do is put them in slope-intercept form. The top one is a vertical line. Okay, this is going to be a vertical line, and that's because there is no y variable. The middle one, I need to subtract that x over, so I have negative 2y is less than or equal to negative x plus 2, because I subtracted x to the other side. Then divide by negative 2. That flips my sign, so now I have greater than or equal to. Negative divided by negative is positive 1/2 x, and then 2 divided by negative 2 is negative 1. The bottom one, the last one, subtract the 3x over, so 4y is less than or equal to negative 3x plus 12, and then divide by 4. Keep your sign the same this time, so less than or equal to negative 3/4 plus x, plus 3. All right, so now let's throw these up there. I'll put this one in blue. X is greater than or equal to 0. So x value of 0 is right there. So the x is greater than or equal to 0 is really the x-axis, and then everything shaded to the right, because greater than 0 goes to the right on the x-axis. The next one is a slope or a y-intercept of negative 1, and then I go up 1 over 2, up 1 over 2, up 1 over 2. This is a solid line that goes like this. And then I want to shade up because I want greater than. And the last one is a y-intercept of positive 3, so up here. And then down 3 and right 4. Down 1, 2, 3, right 1, 2, 3, 4. This again is a solid line. And this time I'm shading down. Okay, so we get much of the coordinate plane covered, and it's kind of hard to see, but hopefully you can tell that there's some red, some purple, and some green in this region right here. Our boundary lines look like this. And again, three inequality lines mean I'm going to have a triangle of some sort. or I guess could give me a possibility of a triangle, because if I use all 3 boundary lines, 3 lines make a triangle. All right, there's my region. Last question. So we have 4 lines in this one. The top 2 are just straight lines. This one's going to be vertical. This one's going to be horizontal. And that's because the top one doesn't have a y variable and the second one down doesn't have an x variable. Oh yeah, this one does have an x variable. What am I thinking? Just kidding. That one's not vertical. Where's my eraser? Or horizontal? Silly. Silly Miss Johnson. Okay. And then the next one down, y is greater than 2x plus 9. That one's already set. This one I need to do some work to. I'm going to subtract x, so that's 3. Y is less than negative x plus 9. And then divide by 3. And I have y is less than negative 1/3 x plus 3. All right, 4 lines to graph. Here we go. So the top one's a vertical line at 2. So x equals 2 is right here. It's a dashed line because it's not including the symbol. And then I want things less than, so I'm going to shade to the left, because less than, as far as the x-axis goes to the left. Next one down, this is why I thought it was horizontal at first, because there's no y-intercept over here. If there's no y-intercept shown over here, that means my y-intercept is 0. But then I do have a slope with the x variable, so I go up 1 over 4, up 1 over 4. This again is a dashed line. And I want to shade above it, so I'm up here. The next one, positive 9 is my y-intercept, so I'm 1 off the coordinate plane that's given to me. And then my slope is 2. Now it's going to be hard to go up and over when your coordinate plane is already done, so I'm going to go down 2 to 7 and back 1. Then down 2 to 5 and back 1, down 2 to 3 and back 1, and so on. This is again a dashed line. And I want values greater than, holy buckets, this is going to be crazy. When you put more, the more lines you have on the coordinate plane, the more messy it gets. And then the last one, y-intercept of positive 3, and then I go down 1, right, 1, 2, 3, down 1, right, 1, 2, 3. And this again is a dashed line, but I'm shading down. Okay, so now let's see if we can find where the overlapping region is. So I need to be above this green. I need to be above this red. I need to be above this green. Where does the green go to? And I need to be below this purple. I also needed to be left of the blue, but the blue isn't even touching this region over here, so I'm not worried about it. I'm already fulfilling that. So here's the region that I have. And holy cow. Craziness. All right, we made it to the end of the notes sheet. Thanks for listening, and don't forget to check your notes off with Ms. Johnson, and I will talk to you all later.